This is the first section of the hypothesis testing chapter from Further Statistics 1, and here we're testing for the mean of a Poisson distribution. So first thing we're going to do is just go through some hypothesis testing basics, because the same rules apply for any type of hypothesis testing. So if we understand the basic rules for hypothesis testing, then we should be able to do any hypothesis test. So the first thing, we'll need to state what H0 and H1 are. Now, whatever hypothesis test you're doing, H0 basically means nothing is wrong, okay, or nothing has changed. Nothing is wrong, nothing has changed. Whereas H1 is always going to be something has changed, or something is wrong. Now that might be that a probability has changed, something like that, but H0 is always going to be nothing is wrong. It's as we'd expect it to be. H1 is always something's changed, and it's changed significantly for us to be able to say, right, we don't, H0's not correct. So how do we decide whether that is? Well, these questions always involve working out some sort of probability. So you work out a probability and you compare the probability to the significance level. Compare with the significance level. Now that significance level may be 5%, 10%, 1%, but remember, if it's a two-tail test, then you need to halve the significance level. So remember that. So you've got your worked out probability, okay, the probability that you've calculated. So we've got our calculated probability here, and we've got our significance level over here. Now, if our calculated probability is greater than the significance level, so if we had a greater than symbol there, one way of thinking of it is like the significance level is like the cutoff point. Anything below that we say is strange, there's something wrong. Anything above that we'll say it's fine, it's likely that that thing could have happened. So if our calculated probability is greater than our significance level, that's going to lead us to believe that there's nothing wrong. Yeah, it's bigger than our significance level. So if our significance level is 10% and we calculated the probability of this thing happening at 30%, then, well, we'll say there's nothing wrong. So if our calculated probability is greater than our significance level, that's going to lead us to accept H0. Okay. If, however, our calculated probability is less than our significance level, then that's going to give us evidence to suggest we're going to reject H0. Yeah, another way of saying that is that you're going to accept H1. Yeah. So hypothesis testing always has these steps. Number 1, what's H0 and H2? Number 2, work out a probability. Step 3, compare it with your significance level. Step 4, either accept or reject H0, and then step 5 is always going to be some statement in the context of the question. Yeah, so look at what the question's about and make sure you write down a statement which is in the context of that question. Now, because we are looking at a Poisson distribution, H0 is going to be that the mean is, okay, unchanged from what we expect it to be. H1 is going to be that the mean is either greater than, less than, or not equal to what we expect it to be. What we expect. And you know that if this is not equal to, that's going to be a two-tailed test, and there's some stuff mentioned at the bottom there about what we do to the significance level with a two-tailed test. So H0 is always going to be the mean hasn't changed from what we expect it to be. H1 is always going to be the mean is either greater or less than or not equal to what we expect it to be, and we'll find that information in the question. Right, accidents occur at a certain road junction at a rate of 6 per month. The residents petitioned for traffic lights. In a month after lights were installed, there was only one accident. Test at the 5% significance level whether there's evidence that the lights have reduced the number of accidents. So H0, we assume that the mean rate hasn't changed. Okay, so that's going to be that it was 6 and it's not changed. H1 is going to be that it has changed. Now it says something that the traffic lights have reduced the rate of accidents. So H1 is going to be that the mean is now less than 6. So that's telling us straight away we're going to be doing a lower tail test. We've got a significance level of 5%. And when we assume H0 is true, then we work out, well, what's the, we need to say what X is, our random variable. Let's do that. So this question is about the number of accidents at a road junction. So I'm going to put down X equals number of accidents at a road junction. Right, so what are we working out? Well, the rate of accidents at a road junction is distributed with a Poisson distribution. I'm assuming H0 is true at a rate of 6 per month. And it says that after the lights were installed, there was only one accident. So we want to work out, well, what's the probability that there's going to be one or less accident at a rate of 6 per month. So if nothing had changed and you had one or less accident a month, what's the probability of that happening? So menu 7, we want Poisson CD, and X is going to be 1, lambda is 6, and I get 0.0, 4 decimal places here, 1735, so it's 174. Okay, right, so now we've calculated our probability. Let's compare that with the significance level. So our probability is this. Our significance level is 5%. Now I can see that my calculated probability is less than the significance level. So what does that tell me? Well, the probability of up to one accident a month happening is about 1.7%. Our cutoff point is 5%. Anything below 5%, we're saying something is wrong. So what do? That's just telling us that we're going to reject H0, because testing H0, we've only got a probability of 1.7%. And our significance level is 5%. Anything below 5%, we're saying is something has changed, something is wrong. Anything over 5%, we'll say nothing has changed, nothing is wrong. So when we write reject H0, really, we shouldn't just write reject H0. Okay, you'd say something like this: there is enough evidence to reject H0. Now there's different ways you could write this sentence. You could write there is insufficient evidence to accept H0. Yeah, so you could write one of the other of those two statements. They basically mean the same thing. I think the second one sounds a bit better. Really, there is insufficient evidence to accept H0. And you say something like, therefore, we reject H0 at the 5% significance level. That's the level that we decided to test our probability at. And then a sentence in context, something like, there is not enough evidence, or no evidence, not enough evidence to suggest the number of accidents has reduced. Or you could say something like, it's not enough evidence that the set of traffic lights has reduced the rate of accidents. Now, if we chose a different significance level, we come up with a different conclusion. If my significance level, for example, was 1%, yeah, so if this here was 1%, then our probability would be greater than 1%, in which case we'd accept H0. Yeah, so depending on the significance level, how strict we want to be about our test, then we'll come up with a different conclusion. Over a long period of time, Fatima found that the bus taking her to school was late at a rate of 2.5 times per month. In the following months, following the start of the new summer bus schedules, Fatima finds that a bus is late 6 times. She has observed it to be late 6 times. Assuming that the number of times a bus is late each month has a Poisson distribution, test at the 2% significance level whether or not the new schedules have changed the frequency. Right, so all the information we need to answer this question is here. So first of all, if nothing is wrong, what should be the rate at which the buses are late? 2.5. This question says, has the rate at which it's late's changed? So changed is not equal to 2.5 a month. Now there's a 2% significance level, but because of the change symbol, this is a two-tail test. So that means actually our significance level becomes 1%. And right, what's X going to stand for? Okay, so it's going to be the number of times the bus is late. And we're told that X is a Poisson distribution, and we always test H0, so that's going to be 2.5. And we want to find the probability. Now we need to decide whether it's going to be greater than or less than. So what do? We always look at our observed value and compare it to the mean. Now, if our observed value is greater than the mean, we do an upper tail test. If our observed value is less than the mean, we do a lower tail test. So you could think of it like this: greater than, upper, less than, lower. Yeah, and that will tell us whether to do an upper or a lower tail test. And what did we have here? Our observed value was 6 lates, and our mean is 2.5. 6 is greater than 5, so we do an upper tail test. So let's continue this down here. So there's our Poisson distribution 2.5, and we want to find a probability. Well, if the rate of buses or the rate of lates is 2.5 a month, and they're saying that observe 6 times a month, what's the probability that 6 or more buses are going to be late at a rate of 2.5 a month? So this is going to be 1 minus the probability of x is less than or equal to 5. That's going to be 1 minus, so Poisson CD, and variable x is 6, lambda is 2.5. So I get a value of, I think I said x is 6, sorry, x should be 5. So that's going to be 0.95. Now it's 8797. So if I round it to 4 decimal places, be 80. So to get the full answer, I'm going to go menu 1 and do 1 minus answer, and I get 0.0420 to 4 decimal places. So we've calculated our probability. Compare the calculated probability to the significance level, and the significance level we said was 1%, which is that, because we're just doing an upper tail test. We split the significance level in half, and our calculated probability is greater than the significance level. So if it's greater than the significance level, that means we accept H0. Yeah, it's what we've worked out. We've decided is likely to happen because it's bigger than 1%. So you can write the next statement in one of two ways. You could say there is sufficient evidence to accept H0, or another way of doing it, let's do a different colour, there is insufficient evidence to reject, put the word evidence in, insufficient evidence to reject H0. Either way, we reject H0. So what does that mean? We'll finish it off by saying there is not enough evidence, to suggest the number of lates or bus lates has changed. Yeah, there's not enough evidence to say it's changed because we're accepting H0. So you might say something about the bus schedules or something like that, but we must have that conclusion at the end. Okay, this is an apt question. During an influenza epidemic, 4% of a population of a large city were affected on a given day. The manager of a factory that employs 215 people found that 17 of the employees at his factory were absent, claiming to be suffering from influenza. Using a Poisson approximation to the binomial distribution and at 5% significance level, test whether or not the proportion of employees suffering from influenza at his factory was larger than the whole city. So the first thing we do, we're going to write this question out as if it was a binomial hypothesis test, but the working is going to be hypothesis, Poisson. So everything we do to start with is going to be as if this was a binomial. Right, okay. So first of all, what's the proportion of people if nothing was wrong at the factory? Okay, 4%. He says that the proportion of people at his factory was with suffering from influenza was larger than that of the whole city. So is the proportion of people greater than 4% at his factory? That's what we're going to test. Now, X, what's X going to stand for? Okay, this is going to be the number of employees out of these 250, number of employees with influenza. So actually it's actually a type of COVID, I'm guessing. Right, and with a binomial, right, what's this guy got? He's got a sample of 250, and the probability they're going to have influenza is 0.04. And what we want to find, since this is an upper tail test, is what's the probability that 17 or more of his employees have got influenza. Okay, so that's the binomial part, and I suppose we could then say, right, well, that's going to be 1 minus the probability of x less than or equal to 16. So the rest of the question, we're going to take those values and we're going to do a Poisson distribution. Okay, so using a Poisson approximation. So remember, with a Poisson approximation, the mean is equal to n times p. So we're going to choose a value of lambda of 250 times by 0.04. So 250 times 0.04 gives me 10. Right, so a Poisson approximation, X still stands for the number of employees with influenza. So I could still use X, or I could use a different value. So X is going to be a Poisson distribution with a rate of 10, and I want to find a probability that more than 17 of these employees have influenza, which is 1 minus the probability less than or equal to 16. So it's going to be 1 minus. So let's go to Poisson CD variable. X is going to be 16, lambda is going to be 10, and I get 0.97, then it's 295, so 30 to 4 decimal places. Now here I'm going to go back to my calculator, and I'm going to do 1 minus answer, and I get 0.0270 to 4 decimal places. Okay, so I've got my calculated probability. Let's compare my calculated probability with the significance level, which is 5%. Let's leave it as 5%. So that means my calculated probability is less than the significance level, which means it's low. That would cause me to reject 80. So let me answer this one slightly differently. So I'm going to write reject 80, and I would say there is evidence to suggest the number or the proportion of employees with COVID influenza is higher than in the city. Right, you should now be able to do exercise 4A and pages 61 to 62. So just a reminder about what each one of your questions should have. H0 and H1, and it's going to be the mean is equal to something. The mean is either not equal or greater than or less than. I think in the book they used the letter M for basically the rate at which things happen. So this is either going to be greater than that, less than that, or not equal to that. This is going to be two-tail, which means you halve the significance level. Then you're going to state what X stands for, the number of whatever. Then it's going to be a Poisson distribution where you're going to work out the probability of X. Now this is either going to be greater than or equal to or less than or equal to. Okay, the tail of the test will tell you whether it's greater than or less than. And then if you're not sure if it's a two-tail, then compare what you've observed with the mean, and that will tell you whether you do an upper tail test or a lower tail. And then what goes here is going to be what you've observed, what was observed in the question. They saw 3 people with this, they saw 17 people with flu, whatever that is. You calculate that probability, and whatever you get here, you're going to compare with significance level, and if your calculated probability is greater than the significance level, we'd accept H0 is likely. If our calculated probability is less than the significance level, we reject H0.